Hi everyone, this is the first in a series of videos where I'll be talking about important topics within the realm of finance. We'll start off with the topic time value of money, which also could be referred to as the money value of time, and we'll work through some examples of that, and I'll explain things in detail so you grasp the concept. So it's simple. If someone asks you, would you rather receive $10,000 today or in 3 months, you'd answer, I'd rather receive it today. And if we do away with uncertainty and just say that you'd get it in 3 months if you chose that, no matter what, it boils down to the fact that if you got $10,000 today, you could invest it in something or just put it in a savings account. And in 3 months, you'd have some extra money, more than $10,000 had you chosen to receive $10,000 in 3 months. So that's the simple idea, no more complex than that. So now let's just see what happens when we deposit money. Let's assume our interest rate, which I'll refer to as R, is 10% per period. Okay? And a period is a length of time between two dates. Let's refer to the current moment as date 0, and 1 period from now is date 1. Okay, so if I have $100 in the bank at date 0 and I don't add any more money and I don't withdraw any money from the account, at date 1 we'll assume that the account will accrue interest at 10%, or the balance of my account will be seen to be $110, okay? And just the simple arithmetic behind that is as follows. We have a future value, in this case at date 1, which is equal to the value at date 0 plus the value at date 0 multiplied by the decimal form of 10%, 0.1, okay? So this is what we have. And then, of course, we can factor out the V sub 0, the value right now, and we would get 1 plus 0.1, or we have the future value at date 1 is equal to the value at date 0 times 1.1. Nothing surprising about that. So if I start off with $100 at date 0, at date 1 we'll have $110. Okay? Simple. Of course, this simple exercise can be extended. I'll try to put it like this so you can see it, I hope. And let's say we leave the $110 in the account at date 1. Here, sometimes a cash flow date line is a neat way of showing this. So here is date 0, here is date 1. And at date 0, we deposited $100 in actual cash flow into the account. And then we just calculated at date 1 that the value of the account would be $110. The $10 of interest is accruing. I'm not actually making a deposit, although that money is being deposited into the account by the bank. So I'm just going to put 110 up here to show the value in a little rectangle to show the value at date 1. And the question now we might look at is what's the value in the account we expect to have at date 2, assuming we make no assuming we make no withdrawals and we make, by assumption, no additional deposits. Well, future value at date 2 would be the future value at date 1 plus, I'll just say the value at date 1, excuse me, a little clearer for you. Plus the value at date 1 times 10%, and factor out the V1. We have V1 times 1 plus 0.1, and that's going to give us the future value in the account at date 2. However, we look back up here, and we see that we defined the value at date 1, the future value at date 1, as V0 times 1.1. I'm going to plug this V0 times 1.1 right in here for V1. And so we have future value at day 2 is V0 times 1.1, and I'll bring this down, 1.1. And then we see our little equation becomes V0 times 1.1 squared. Or more simply, the future value in the account at day 2 is the initial value at date 0 in our example, $100 times 1.1 squared. 1.1 squared happens to be 1.21, so we have $100 times 1.21, or $121, the future value in the account at date 2. Okay? Just for clarity, let's go one more period and see what happens to the account balance one period in the future. So we just saw that the balance in the account was 121 at day 2. What's the expected balance in the account at day 3, assuming we make no withdrawals and no additional deposits other than the interest the bank is giving us? Okay, so now the question is, what's the balance at day 3? All right, so now the value in the account, or the future value in the account at day 3, is going to be the value in the account at day 2 plus the value in the account at day 2 times the assumed interest rate of 10% per period, which is going to be the value at date 2 times, just factoring out the V2, 1 plus 0.1, or V2 times 1.1. And what we have just seen here is the future value at day 2, look at it right here, was equal to 100 times 1.21. So I'm going to plug that in for this V2. So 100 times 1.21. Now 1.21 was 1.1 squared, so I'm going to write it like that. And then I'm going to bring this 1.1 down. And the future value at date 3 becomes this, which of course is 100 times 1.1 cubed. 1.1 squared times 1.1 to the first power. When the base is the same and you're multiplying terms, we add the exponents. 2 plus 1 is 3, so 100 times 1.1 cubed. This is the future value in the account at day 3. Now, of course, we're assuming a no-tax world. In the real world, interest income is likely to be taxable unless it's accruing in a tax-deferred account, but that's silly institutional nonsense we need not be concerned with here. So the value in the account at date 3 is 100 times 1.1 cubed. And at this point, I think we're ready to make an observation. The observation is this. What's the future value in the account at any date? Let's call it date N. Well, the future value in the account at date 3 was this. The future value in the account at date 2 was this. And not surprisingly, the future value of the account at date N is going to be our initial assumed value 100 times 1 plus the assumed rate of interest raised to the power n. So the future value at date n in the account is 100 times 1 plus r to the nth power. In our most recent portion of the example, n was 3, r was 0.1, and of course 3. Okay? And so there is our first example. Now this term right here, 1 plus r to the nth power, that has a name. It's a factor, one of many factors we use in finance to help us solve time value of money problems. And so this 1 plus r to the n factor has a name, and it is called a future value interest factor. Future value interest factor. It's a factor. Okay? And that's the factor. And then there's a very important application formula that we'll use that with. And the application formula is simply the future value, which is measured in dollars, is equal to the present value, measured in dollars, times that future value interest factor, or, dropping the dollar signs, future value equals present value times 1 plus r to the n, where n is the date in the future where we're interested in seeing our account value based upon an assumed initial amount, initial value, called the present value, and assuming compounding at an interest rate r once per period for each of the n periods. So simplistically, if we start off with $100 and we're curious as to the value in the account at date 10, it will be 100 multiply 1 plus r multiplied by 1 plus r to the 10th power. That's straightforward. And so this, again, 1 plus r to the n power is our future value interest factor, and that's used in this application formula. Future value equals present value times FVIF. Now, one thing very important to keep in mind is that in using this n, the variable n refers to the number of periods that we're moving ahead into the future. Okay? In this first example, we started at date 0 because it's appealing to do that. But the interpretation of n is always, no matter when we start, it's always the number of periods we're moving forward in time. Okay, so that's our first interest factor, future value interest factor. And a simple problem that goes with that. That would look something like this. If we assume a no-tax world, that is a world where interest income is not taxable, how much would be the balance would we expect to have in our account if we deposit $1 million at date 0 at an annual interest rate of 5%, and we're concerned about the balance in the account 5 years later? Okay, so in this example, our opportunity rate of return, our assumed rate of interest in this case, is 5%, which of course is 0.05. And in this case, n is 5 years. Okay, so let's see what we have. Well, the future value at date 5 will be equal to the present value multiplied by 1 plus r to the nth power. Here we said that the present value was $1 million. So the future value at date 5 will be the present value, $1 million, multiplied by 1.05 to the 5th power. Okay, so that's our answer. 1.05 to the 5th power multiplied by 1 million. 1.05 to the 5th power, of course, is going to be something more than 1.25. Right? So we're going to have something more than 1,250,000. Why? Because the 5% of 1 million or $50,000 interest that is earned in the first period will itself earn interest in periods 2, 3, 4, and 5. And those impacts are captured in what we're seeing here.